Professor, RMK College of Engineering and Technology. Today, our topic for discussion today our topic for discussion is about nanochemistry. In this, we are going to discuss about size-dependent properties. So, in the last class, we have seen that how small the nanoparticles are there and how suddenly these nanoparticles becomes more stronger than the existing models. For example, when the particle size are broken down into smaller nanoparticles, they become even stronger, harder, and it becomes more effective with high efficiency than the normal material. So the nanoparticles affects many properties such as melting point, boiling point, band gap, optical property, electrical property, and magnetic property. So these properties will change with respect to the size of the nanoparticles. So firstly, the nanoparticles have a relatively larger surface area when compared to the same mass of the material produced in a larger form. So these nanoparticles, when they are very small, that is, when they become very smaller in size, the surface area becomes larger, and this will be chemically reactive and affect the strength or electrical properties. We have already seen about the different dimensions of the nanoparticles in the last class. Now, we have also seen that what really the nanoparticles mean, how small the nanoparticles is. And at the nanoscale, the physical, chemical, and biological properties of material also changes in a fundamental and valuable way from the properties of individual atoms and molecules or with the bulk matter. So, depending upon the particle size, it becomes a cluster or become a nanowire, it can become a nanotube, or it can become a two-dimensional thin film nanocomposites, or it can also even become nanocoatings also. So depending upon the particle size, it also varies. So why nanoparticles? So because of the new property they exhibit compared with the larger particles of the same material, the properties obviously will change. So for example, if we take a titanium dioxide, zinc oxide, which becomes more transparent in nanoscale level, and it can be used in sunscreens. In It can also be used in textile industry, paint industry, as we've already discussed. It can also be used for drug delivery because of the smaller size and larger surface area. It can be used for packing the drugs and delivering it to the specified space of where it has to do the treatment. In the same way, examples of nanostructures, the carbon nanotubes already we have discussed, proteins, DNAs, single electron transistors are examples of nanostructures. Now, why this size dependent properties? The nanomaterials are classified as nanoparticle, nanocapsule, nanofiber, nanowires, fullerenes, nanotubes, nanosprings, nanobelt, quantum dots, and nanofluids. So depending on it, so we are going to quantize them in terms of a rectangular as well as curvilinear fashion. This is how it represents, like how this is how the bulk particle will be, and this is how the dot particle will be. The same way, bulk in the curvilinear and dot in the curvilinear form, it is shown in that way. And this is how the clusters, nanowires, nanotubes, films, coats, and polycrystals look like. And what is this nanorods? So nanorods will be in the form of sticks, and it will range in the diameter from 1 to 100 nanometer. And this can be used in display technologies. It can be used in MEMS, that is micro electromechanical systems. And also these nanorods absorb in the near IR and generate heat, which is used for cancer therapeutics. And it can also used for treatment of tumor cells. Nanoclusters, it is used in the manufacturing of quantum dots, magnetic domain structures. It is also used with larger clusters. We can go in for this nanocrystalline films. and thin films which can be grown easily, and eradication with high energy cluster ions. It is used in the manufacture of high standard thin films for shallow implantation of cluster materials and surface cleaning. And it can also be used for electronic devices for data storage or for fostering chemical reactions. This is how the carbon nanotubes look like. There are two types of carbon nanotubes, single walled and multi-walled carbon nanotube. This is an example of multi-wall, and this is how your armchair model will look like, and this is how your zigzag model look like. It will have a zigzag structure, that is, it will be in this structure zigzag. So armchair will be like this. How we will go on for sitting in the armchair, we'll keep the hands and sit. So that's how the armchair model will look like. And this is a chiral carbon. So chiral, how it is bonded. See how it is bonded. You have a circle shape. It is bonded with the other carbon atoms. So this is the pictogram of nanotube structures. This is the SEM analysis, scanning electron microscopic analysis. You can see the nanoparticles which is being grown. This is also a structure multi-wall. And what is a nanowire? So nanowire will be having a diameter in the ratios length to width ratio of 1000 or more, and you know that it is a one-dimensional material, 1D, and it is used in electronic and nano electromechanical devices. It can be used as an additive in advanced composites as layers. It can be used in metallic interconnects. It can be used as lids for biomolecular nanosensors. They are also used to link tiny components into extremely